Bueno, buenos días, bienvenidos a esta...
Good morning and welcome to this conference. My name is Germán Azis and I am a member of the development team of GeneXus. I've been working in the GeneXus M version, and I would like to tell you about the state of the art, where we are standing, where we go. And last year I made a presentation about what we were doing. So what's the context of this version? Let me tell you what it's about. Maybe you don't remember what we wanted to do with it. GeneXus M was born in order to be a multi-platform that could be used in many operational systems and even in the web environment. The motivation obviously was that we have a big fragmentation in the market share of operating systems, and also we wanted to have continuity in the user experience, to make it easy to go from one environment to the other. So in order to build a version of this with these features which are ambitious, we had to re-engineer our architecture. With regard to the logical architecture, we separated the IDE from the GeneXus services, and by this, I mean the deployer of applications, the management of KBs, etc. With regard to the physical architecture, we wanted to build a cross-platform IDE which could be used in the main operating systems of the market, which would be free of charge, and which could be connected to GeneXus servers. With regard to the services, we want them to be deployed in any place, in the cloud, in a server, in a private network, or maybe installed locally. With regard to the IDE Win, or the Win IDE, it is very mature right now. The evolution has not stopped, and it will connect with the services. For the communications between the IDE and the services, we are using REST and sockets services, which allow us naturally to publish these services like an API which is open to everyone, and by this, we allow some modeling tools to come up, some based in the web or others can be 3D. And this is not only for the users, but also for the designers. There may be modeling tools that will allow other players to enter the development activities with GeneXus around the heart of GeneXus. With regard to the services, we have a scalable architecture. Those who connect to these services can work with our personal KBs, and of course we have the GX server in the middle, and this is a big evolution. We have the build servers that will be using a set of machines, and this is how we are designing this version and what we want to achieve. With regard to the development process we have been following, we adopted an incremental iterative process, but we want each iteration to solve a real scenario. The first one, which I showed last year, was this one. We built a POC, and the objective was to be able to declare a transaction, declare and generate a transaction. The focus was to explore and validate implementation alternatives and deepen our know-how. The result was our first implementation of the GX services to expose basic services to handle and build KBs, to have an IDE for the basic X platform, and also to rethink the modeling with GeneXus. For the IDE, we made a fork Atom, which is extensible, open source, and uses web technologies to develop the graphic interface of a native desktop application. With that, we established the fork. That was the first iteration. For the second one, which is the one we are finishing now, our objective was to declare the business backend of an application, that is to say, to define the logic of the application without considering the UI and put it as a web API. For example, can be developed with the Angular generator. And the focus here was the architecture, especially the architecture of the IDE, having a solid base on which to continue working. For the IDE, we continued using Atom, but with some changes in the architecture, because what we achieved with the POC in the first iteration required changes in the architecture in order to obtain something sound. So we started with the Atom fork, and we built the IDE, which is valid because it's extensible, but we wanted to make something a bit more ambitious. And what we did was to use Atom for a closed-platform application with the web technologies for the interface, but on top we put the GeneXus architecture, or part of it, which we have in the WinIDE, using Atom wherever necessary in order to achieve a cross-platform application. And over the architecture, we build the IDE. And I mean by architecture the generic framework we have in GeneXus to build an IDE, all our APIs and abstractions in order to define packages, extensions, editors, tool windows, properties, and reusable components like the grill. All these sophisticated properties that we brought in and we implemented using web technologies and Atom. And with this, we built the IDE. This is a longer road, but the benefits were, firstly, to minimize the dependence over Atom, which becomes encapsulated in the architecture. The dependence does not filter to the rest of the implementation of the IDE. Now we are using a flexible and mature architecture which supports well all the scenarios we have in GeneXus, which are more complex than the ones Atom solves, because it's just a text editor. Besides, the framework allows us to build other modeling cross-platform tools. And finally, many components of this architecture are independent from Atom, and since they are implemented with web technology, they can be reused in a full web environment, for example. And the IDE is no longer a concrete product. It becomes a foundation for other cross-platform modeling products for the GeneXus world. So it was a win-win situation. And now let's look at a demo. The IDE is one more application. I'm going to execute it. It just reconnected. And the first time we use it, I have a simple page that asks me for connection data, connection to the services that are going to solve the operation. So it's asking me for the URL of the services, my username and password. I connect, and I see the KBs in the server. Here I have a pair. I could create others, but I'm going to use this, a simplified version of the demo of the bill. Here I see the objects tree of the KB that I have in the server, and if I click one of them, I can see the properties of the objects, and the property grid is a sophisticated component. It's a series of properties which are not just values. They can be references to other values, so the property grid has to know how to handle them. For example, the module, the folder of the object is complex. I cannot write just anything. The property grid has to invalidate this change. There is a fluent conversation with the server that the property grid has to solve. There are also editors of the properties. Here we have a personalized property editor that allows me to make changes, select a pair from the object for the object, and therefore I can have generic components and I put them in this IDE. And since they are implemented with web technology, they are reusable outside of the IDE. Now, what kind of objects can we build with this IDE? Here we have some transactions, invoice transactions. Like in the previous event, we continue using the text editor to declare transactions, and here we declare the attributes directly in the text. We have another component, which is the onliner, that shows the structure of the transaction, the levels, and I can also see the properties of the attributes in the property grid. I can define other parts of the transactions, like the rules, the regions in the same text, the variables, which I can also declare. So this is the mechanics that we use, and if we like them, we can change the editors very quickly. But let's create a transaction to see how they operate. Something simple to see well how they operate. We are going to add the country, and here we see the attributes. I see the keys. I put in the name, and I'm going to use some properties. I can use a property grid to say it's auto number. I could change it also in the text, and the property grid is instantly reflects the change. Country name, well, we don't have a lot of properties, but here the purpose is the architecture. So I'm going to save this transaction. I'm going to put in customer the country. And if I go to properties, you will see that I see the properties of the attribute in the server, the auto number, the country name, and obviously this has to be so, but I show it so that you don't get the idea that this text is disconnected from the service. Everything is consistent. So I save, and I have this small change. What else can I do? We have the data provider, which has a textual language in GeneXus, so the mapping is direct. We have auto-generated SGs, which are similar to the transaction because it's a hierarchical structure. We can hide the properties in order to have the view of the object, the code, and with these objects we are fulfilling the objective of declaring the backend, the logical backend of the application. So this is fine, it's what we intended by focusing in the architecture in order to continue working, but the user experience is not enough, something is lacking. So we need here the user interface. So we decided to go further and put something experimental. So we added something basic about web panels, an editor. we will have a simple web panel. And when I create it, I see an editor with two parts. On the one hand, we have the web form, which has abstract editors, as we had in the IDE Win, and the SUS part as other objects. So in the web form, we have a toolbox with some controls that I can use. So we are going to put in a grid and some attributes. Country invoice date. Customer name. The invoice total, and let's add something more. We can have a table here with a text box. We can also program an event. You see that the editor is also fluent as in the Win. I can reposition things, and this is implemented with technology so it can be used outside of this environment. If you look at the inspector online, I'm going to have a hierarchy of controls and some properties that can be changed. The button is associated to the enter event. So we are going to define something simple, regions. And this is how I define my panel. So I save it, and let's look at it when we execute it. I start receiving messages from the server with regard to the processes that are going on, and here we have an impact analysis because we made a change in the transaction model. Country transaction, reorganization, I can see the surfing, and the machine is waiting for us to confirm or cancel the organization. The process continues, the transaction will be generated. And we can see the surfing as they are completed. And here we see the developer menu with some things that have already been generated. We have the invoice report, which lacks design because we still don't have design properties, but it is functional. And this is what I wanted: the invoices, the button for the event, and the new transaction that we created, country. And I also wanted to show you that everything that we have generated is deployed as a web API, which is what we wanted. The Swagger, the description of the services, all of the services that we wrote in this business model are deployed and can be consumed as web services. So we fulfilled our goal. So this is the IDE in its current status. We did what we wanted to do and went further with the panels, and it's the basis to continue working. So we have to round it up to have complete forms, and the editor can be reused potentially in other environments. So this is what I wanted to show you in my demo. And this iteration should be available for you to try very shortly. We still don't know when exactly, but the IDE can be downloaded and installed, and you can use our GX cloud or install it with a Docker container. And in future iterations in the short and medium term, we want to complete it. We have a sound architecture, and we also need to work in the user's experience. There's a lot to be done still with regard to usability. We have to complete the properties and also the GX services so that they have the full potential to manage KBs. And in the long term, we want to have cross-platforms GX services. Now you can use them through the cloud, installing a Docker container, but in the long term, the whole cross-platform can be installed, will be installed wherever you want. So these are the comments I wanted to make, what I wanted to show, and we can meet again in the progress. Thank you.